Well, hello again. Okay, so let's continue talking about chemistry and chemical reactions. I know you're getting tired of this. Hang in there, hang in there. Okay, so how do reactions get started? All right, so here's just a quick example for you. If you're going to go snowboarding, you can't start at the bottom of the mountain and go up. You're not going to have the energy to do it. You've got to start at the top of the mountain and you've got to go down. Kind of same thing with chemical reactions. Unless there's enough energy to push them along, they're not going to start going. And that energy is called activation energy. So the minimum amount of energy that's needed to start the reaction. And every reaction has a certain amount of activation energy that it needs to get started. So for instance, if we just mix hydrogen gas and oxygen gas, we're not going to get water. But if we add a spark, if we add heat, if we provide it with the energy that it needs, then those hydrogen and oxygen molecules are going to react and we're going to end up getting water. And again, that's the activation energy. Okay, so in the last lecture, we talked about two different types of reactions and the energy associated with them. We've got an exothermic reaction. That's where energy is being released. And of course, the other one was endothermic, where energy is being absorbed. Let's talk exo first. Energy is being released. And if you take a look at the graph, and I would highly suggest the graph be put into your notes. It's important. You will see it again. But if you look at it, the energy that's needed this is the energy of the reactants before the reaction is taking place. Now, notice what's happening at the end. The products, so what we're ending up with, have less energy than the reactants. They are giving off that heat, they are giving off that energy to its surroundings. Opposites happening for endothermic. If we look at endothermic, if we look at the energy of the reactants compared to the energy of the products, notice the energy of the products is greater. They are absorbing energy that they need for the reaction to take place. Again, this is a highly important graph. Make sure you have it in your notes. Now, different things can also affect the rate of the chemical reaction. Things like surface area, temperature, concentration, and whether or not there's something called a catalyst or an inhibitor. So let's first talk about surface area.
Why so empty in here?
Okay, so getting back to surface area. When a piece of a solid reacts with a liquid or a gas, it's really the particles on the surface that are reacting. So the more surface that we can get into contact with the other reactants, the quicker the reaction is going to take place. So if we break things up, if we grind them, if we increase the surface area, the reaction is going to speed up. A second way to increase the rate of reaction or to change the rate of the reaction is to manipulate the temperature. If we heat a substance up, the particles are going to be moving faster. Those faster moving particles have more energy, and that reaction is going to move more quickly. On the opposite side, if we reduce the temperature, we're going to slow down the reaction. Okay, concentration. That's how much of a substance is in a given volume. So if we increase the concentration of the reactants, we've got more particles that are going to be reacting, and so more reaction is going to take place. And last but not least, the catalyst and inhibitors. A catalyst is actually something that increases the reaction rate by lowering the activation energy. So what happens is the energy that's needed for that reaction to take place is decreased so that it happens more easily. Cells in your body have different types of catalysts, which are called enzymes, that help your cells go through the reactions that they need at your body temperature. And then we also have things called inhibitors, which will decrease the rate of the reaction. Okay, that is it for today. Short and sweet. Hope you enjoyed, and I will see you all later.